Question 10 starts off with a binomial expansion. The power is 6, which is a positive integer. So since n belongs to the set of natural numbers, we can use the a plus b to the n formula. We could use the other one, the 1 plus x to the n formula, but this one's simpler, I think. So let's use that. So part A, we know from the formula book that we just need to do this. N minus 1b plus n choose 2. And we're just going to keep on going. So in our question, we've got 3 plus 2x to the power of 6. A is 3, B is 2x. I would keep that in a bracket so you don't forget to square the 2 and the x, and n is 6. So if we whack that all into the formula above, we're going to get 3 to the power of 6 plus 6, choose 1, 3 to the power of 5 times 2x plus 6, choose 2, 3 to the power of 4, 2x squared plus 6, choose 3, 3 cubed, 2x cubed. And we've still got another term. We need the first 5 terms here. So we've got 1, 2, 3, 4. We need one more term, which will be 6, choose 4, 3 squared, 2x to the power of 4. So work all of those out. We're going to get 729 plus 2916x plus 4860x squared plus 4320x cubed, and then plus 2160x to the power of 4. It did actually only ask us to find the second, third, and fifth terms, but it's not going to do any harm to find some extra terms, although it might take slightly longer. Doesn't really matter. So second, third, fifth terms. Then for part B, it says these terms form a geometric series for a particular value of x. So let's find that value of x. So what the question is saying is that if it's a geometric series, then this term here divided by this term will equal this term divided by this one. So if these are the first 3 terms of a geometric series, we can say that this term 4860x squared divided by the term before it 2916x will equal this term, which would be the third term in the geometric series, 2160x to the power of 4 divided by the term before that, which would be 4860x squared. You could write out the terms if you like again, but it would give you this when you divided successive terms, because that's how you would find r, is to divide the successive terms. So we want to solve this. So we cross multiply, that can go up there, that can go up there. We're going to get some big numbers here: 23619,600. That will equal 629,8560. x to the power 5. Now normally you don't divide by x to the power 4 because that will lose the x equals 0 solution. But x equals 0 would just give us 0, 0, 0. So that's not a particularly great geometric series. So I think we can just divide by x to the power 4 here, and divide both sides by this as well. And that will give us 3.75 equals x. So that's the answer to part B. The next bit of this question, this is getting more and more common in exams, to start off with something like a binomial expansion, and then it turns into a different kind of question, like a series question. So in part 2, it's saying it's a different geometric series now. The first term is sine squared, so let's write that down, sine squared theta. The second term, do we know what the second term is? No, but we can work it out because the common ratio is 2 cos theta. So the second term will be 2 sine squared theta cos theta. And we'll keep multiplying by 2 cos theta. Okay, so what do we know in this question? Well, the sum to infinity we know. So we know this. Let's just write down what A and R would equal. So sum to infinity, it tells us, is this sine squared over 2, 1 minus 2 cos theta. Rearrange that, we get 8 minus 16 cos theta equals 5 sine squared theta. We want to solve that, so let's change all these to coses. Oh no, we don't want to solve it. We just want to show we get that quadratic in cos. So we've got to make sure we show every step of work in here. Multiply that out, 5 cos squared theta. Get everything to equal 0. So we've got 5 cos squared. Let's put everything on the left hand side now. 5 cos squared theta minus 16 cos theta plus 3 equals 0, which we were asked to prove. And final bit of the question, hence find the exact value of the second term. Okay, so the exact value of the second term, if we solve this quadratic, we'll get cos theta equals 3, or cos theta equals 1/5. So which of those do we need to use? Well, we know the series, so this series has a sum to infinity. So geometric series only have a sum to infinity if R is between 1 and minus 1. Otherwise the series will diverge. So therefore we can't have, remember R in this question is 2 cos theta. So we can't have this, otherwise R would equal 6 and it wouldn't converge to a sum to infinity. So this we can forget about. Okay, we're only interested in when cos theta equals 1/5, because in that case R will equal 2 cos theta, so R is 2/5. So let's go back, let's just put that in a box. So we want the second term, so the second term is 2 sine squared theta cos theta, which is 2 times 1 minus cos squared theta times another cos theta. So we know that cos theta is 1/5, so we've got 1/5 squared here, times by another 1/5, and so that will give us 2 times by 24 over 25 times by 1/5, which is going to give us 48 over 125. I've run out of space, but that's the answer. It needs to be exact, and that's the final answer there.